Hello, Amna. Are you getting my voice? Beta, tell me. You can write in the chat box. Are you listening me? Hello. Getting my voice? Please write in the chat box. Then I will start. So we did the Ohm's law. Now today we will study the resistance. So basically in wires or in conductors, there is a property that due to that property, there is a opposition of the flow of current. Means that property opposes the flow of current in the wire, and that property is known as the resistance of the wire. More will be the resistance of the wire, less amount of current will flow in that wire. Okay, so resistance is the property of a conductor due. Hello Martin and Eamon. Hello Eamon. Hello Martin.
Hello, sir.
Why you are late today?
I had like my computer was lagging.
Okay. Hello Eamon. Okay, so we did the Ohm's law. We did Ohm's law. Now today we will discuss the resistance.
Okay,
I
sir.
think you should know what is resistance. Resistance is a property of a conductor due to which this property opposes the flow of current basically. More will be the resistance of the wire, less will be the current flowing in the wire. More will be the resistance of the wire, less will be the current flow in the wire. So basically resistance is represented, we will represent resistance with capital R. What is resistance? Property of a conductor due to which it opposes the flow of current through it. Means through wire if the current is flowing, so in the flow of that current, the resistance will oppose that flow of current. Okay, try to decrease the flow of current. That is the resistance of the wire. So the property of a conductor due to which it opposes the flow of the current through it is called resistance. Resistance we will represent with capital R. More will be the resistance of the conductor, less will be the current in the conductor. We're not talking about the unit of the resistance. SI unit of resistance is ohm. OHM, ohm. Okay, and symbol of ohm is this. Remember this point. Okay. Okay, now I told you that the Ohm's law at constant temperature means that you are not changing the temperature of the wire. You are not changing the temperature of the wire. In that case, the current flowing in the wire is directly proportional to the potential difference across the ends of the wire or conductor. So you will get current is directly proportional to the wire. So you can write potential difference is directly proportional to the current. Basically, this potential difference is directly proportional to the current. And if we will draw the graph between the potential difference and the current, then we will get a straight line graph. We will get this type of graph between potential difference and the current. You will get this type of graph. On y-axis there is current, this is y-axis, this is x-axis. On y-axis there is current, on x-axis there is potential difference. I is representing current, v is representing potential difference through wire, across the ends of the wire. I is the current flowing in the wire. What is potential difference? What is v? V is the potential difference across ends of wire, ends of conductor, and I is the current flowing in conductor. Okay, now this is the VI graph for the metal conductor. So this graph we are drawing for a metal conductor, metal like copper, aluminium. There are other metals also. So we can see we are drawing this graph for the metal conductor. So we will get this graph experimentally. We will get this graph as a straight line graph like this. We will get this graph as a straight line graph. Now there is one term that is known as the slope of the graph. So the meaning of the slope is this. The amount of tiltness in the graph. Suppose if this is a graph, na? This is a graph. Slope means this means less slope. This means more slope. Less slope, more slope. Less slope, more slope. Okay. Basically, slope of this graph. Okay. If you will calculate this angle is theta, then slope of the graph you will get tan theta, and that is equal to V upon I. And what is V upon I? Resistance R. So basically the slope of the graph is given by the resistance of the conductor, and you will get a straight line graph for metal conductor. Okay. I think you will have experiment also in your lab where you will draw a graph between the current and the potential difference. Okay. After this, we will discuss the factors affecting the resistance of the conductor. Or the factors affecting on the resistance of a wire or a conductor. Suppose if you are increasing the length of the wire, then what will be the resistance? Will the resistance increase or resistance will decrease? Suppose if you are increasing the area of cross section. So what is the meaning of area of cross section? Suppose this is a pen. This is a pen. For this pen, the area of cross section will be this area. Are you getting it? This area. This front area will be the area of cross section. You can see this is circular. This area is circular area. So this area will be considered as area of cross section. So if you will increase the cross section area, means if you will increase the thickness of the wire, then what will happen? Resistance will increase or whether it will decrease, we will see. If you will change the material of the wire, suppose initially you have the copper wire, then what is the resistance? Suppose after some time you are checking the resistance of the aluminium wire and you will compare the resistance of both the wire, and you will see which wire will have the more resistance having some specific length and area. Okay, so we'll discuss that. I am telling you, if you will increase the length of the wire, resistance will also increase. So resistance is directly proportional to the length of the wire. If you will increase the area of cross section of the wire, then resistance will decrease. Okay. So there are few points that I have written. Length of the conductor. So if you will increase the resistance of the wire, R is the resistance of the wire or resistance of the conductor, is directly proportional to the length of the conductor. So resistance is directly proportional to the length of the conductor. Okay. After that, second point, area of cross section or thickness. I told you what is area of cross section now. Resistance is inversely proportional to the area of cross section, means if you will increase the area of cross section, resistance will decrease. Directly proportional means increasing length will increase the resistance. If you will increase the length of the wire, then the resistance of the wire will increase. If you will increase the area of cross section, then resistance of the wire will decrease. It means that increasing area inversely proportional means increasing A will decrease resistance of the wire R. R is the resistance of the wire. So you can say resistance of the wire is inversely proportional to area A. After that, nature of the material of the conductor. For same dimension means, suppose I am taking this is one wire. Okay, this is a one piece of wire and this is another piece of wire. Both have the same length and same area of cross section. So this is of copper and this will be of aluminium, having same length and same area of cross section, both the pieces of wire. If I will calculate the resistance of the copper wire of same length and same area of cross section, means same dimension, then it will be less as compared to the aluminium wire. For same dimension, copper wire has low resistance as compared to the aluminium wire. So means if you will change the material of the conductor, then also there will be change in resistance, whether it can decrease also, it can increase also, depending upon the nature of the material. Suppose initially you have aluminium wire, aluminium wire of same dimension will have more resistance, but suppose finally you have taken the copper wire will have more resistance, less resistance. After that, temperature. For metals, if you are taking a wire of metal, suppose this is a wire of some metal like copper, and if I am increasing the temperature of this wire, then in that case resistance of this wire will increase. Okay, now you can see here it has been found that experimentally these all things we found experimentally. Okay, it has been found that resistance of all pure metals like copper, aluminium increases on increasing the temperature and decreasing on lowering the temperature. If you will increase the temperature, resistance will increase. If you will decrease the temperature, resistance will also decrease. Now there is one more point, but resistance of the alloys. Alloys means these are the compounds which are made up of more than two elements. Like manganese is made up of manganese and tin. Okay, like constantan and nichrome. Nichrome is made up of the nickel and chromium. Okay, but the resistance of alloys like manganese, constantan and nichrome always is almost unaffected by the temperature. So what they are saying, if you will take alloy means, you know what is alloy. Alloy is made up of more than two elements. If you will combine more than two elements in proper proportion, then you will get an alloy. Like nichrome, like manganese, these are the some alloys. If you will increase the temperature of the alloy, then it is seen that, and it was found that the resistance of the alloys is not changing much. Means you can say resistance of alloy will remain constant. First note down from here, then we will discuss further. All of you note down. Aman, Hamna, Martin, Abdullah, write down. Done? Aman, Hamna, Martin, Abdullah, completed?
Yes, sir.
Okay. Now write down fast this. Write down this graph. This is a straight line graph. Straight line. Write down fast. Completed?
Yes, sir. Completed.
Okay. Write down this. Ask me to scroll down when complete. Okay. Martin completed. Okay, take your time.
Good answer.
Done. Hamna completed. Okay, so write down this one. Okay, we will wait for 2 minutes. Okay. Completed. Martin, Hamna, Aman.
Yes, sir.
Okay. So now see here. Martin completed.
Yeah, answer.
Okay. So remember these 2 points. Resistance is active proportional to length. Resistance is inversely proportional to area. I will use these 2 things to drive the resistivity formula. Resistivity. There is a term resistivity that we will discuss here, and that resistivity is also known as the specific resistance. Okay, a specific resistance. Now see, we know that Resistance of a wire is directly proportional to the length of the wire. Resistance of the wire is inversely proportional to the area. Now, suppose this is equation number 1, equation number 2, combine both the equation. We will now combine both the equations. So I can write resistance is directly proportional to length, inversely proportional to area. Now I told you that there in Ohm's law, potential difference is directly proportional to current. When I have removed the proportionality sign, so there will be a new constant that is known as the resistance. In this case also, when I will remove this proportionality sign, there will be a new constant, and that constant is resistivity. Rho. Resistivity is represented by symbol rho. Okay, this symbol is basically known as RH or rho. Rho L divided by A. Sorry. This is the resistivity. So there is a relation between the resistance and the resistivity. Okay, so I will recommend you to learn this formula. R is equal to rho L by A. Otherwise, if you want to find resistivity from here, you will get resistivity also. Rho is equal to RA by L. No problem in that. But you, for numerical purpose, okay, use this formula. And unit of resistivity is ohm meter. You can calculate that also. For calculating unit, I told you from the formula we can calculate unit. So this is resistivity is equal to resistance into area into length. Now tell me the unit of resistance. Ohm. Tell me the area of unit of area, meter square. Unit of length, meter. Meter and 1 meter will be cancelled out. So unit will be ohm meter. Ohm meter will be the unit. SI unit is ohm meter. Now, after that, if I want to define resistivity, then what I will do, I will write this formula. I will take length as 1 meter. I will take area as 1 meter square. And then I will get a resistance of is equal to resistivity. And that will be the, basically resistivity is a resistance of unit length wire and having unit area of cross section. You will write R is equal to rho L by A. If area you are taking 1 meter square, length of the wire you are taking 1 meter, then you will put area and length in this formula. You will get resistivity R into 1 into 1. Resistivity of the wire will become resistance. Then you can define resistance of a resistance. What is the resistivity? Resistance of a wire of unit area and unit length is resistivity. If you are taking a wire of unit length and that wire have unit cross section area, and then you will calculate the resistance of the wire, that resistance of the wire will be specific resistance or resistivity. Okay, write down fast. Then we will solve numerical. Scroll down.
Good answer.
Okay. So remember this formula: resistance is equal to resistivity multiplied by length divided by area. R is equal to rho L by A. This is a symbol of resistivity rho, or this is also known as specific resistance. If in exam, if someone is asking what is the resistivity, then you can define resistivity. Resistivity is the resistance of a wire having unit length and unit area. Completed.
Good answer.
Now we will solve numericals. First numerical. Numericals are more important here. This is a question of NCERT. Okay, I have taken a question of NCERT. In this question, they are saying, first of all, read the question. A copper wire has a diameter of 0.5 mm. A copper wire has a diameter of 0.5 mm, and that copper wire have resistivity of 1.6 into 10 to the power minus 8 ohm meter. What is given? Resistance of the wire is given. Resistivity of the wire is given. Okay, resistivity rho. What will be the length of this wire? What will be the length of this wire to make its resistance 10 ohm? Sorry. This is the diameter of the wire. D is the diameter. Diameter of the wire is 0.5 mm. Resistivity of the wire is 1.6 into 10 to the power 8 meter per second. 1.6 into 10 to the power 8 ohm meter. Sorry. What will be the length of wire to make its resistance 10 meter? So resistance is 10 meter. For example, you can take wire. This is a wire. Okay. Wire, and this wire having the diameter means you can take wire in this form, because wires are like this. Area of cross section of wire will be this. This will be the area of cross section. I told you what is the area of cross section. So this will be the circular area. This circular area will be the area of cross section. What is given? Diameter of this wire is given D. That will be 0.55 mm. First convert the millimeter into meter. Mm means millimeter. So diameter is 0.5 mm. 0.5 mm it will be. First we will convert this mm into millimeter into meter. So in 1 meter, there are 10 to the power 3 millimeters. Okay. So in 1 millimeter, there will be 10 to the power minus 3 meters. So we will multiply this value with 10 to the power minus 3. So diameter we will have in meters. Okay. We can convert this value in radius also. If I want, then I want to calculate this area of cross section A. Okay, area of cross section A. So it will be pi by 4 into d square. This is a circular area, na? Area of, what is the area of circle? Pi r square. Pi r square, na? So you can convert radius into diameter. So radius is half of diameter. So you will get pi by 4 into d square. Okay, I have written directly here. Is there any problem? Okay. Okay. Okay, so this area will be here and this is here. Pi by 4 d square. So pi by 4 d square means 0.5 into 10 to the power minus 3 square. In this question, you have to do calculations. 0.5 into 10 to the power minus 3 and the square of it. So this area we have, and this will be in meter square. Now another thing, they are asking length of the wire. Length of the wire is asked. And what is given? Resistance given. Resistance of the wire is 10 ohm. Because we want to make the resistance of wire 10 ohm. Resistance is given. Resistivity rho is given 1.6 10 to the power minus 8 ohm meter. Diameter is given, so we have calculated the area. Now we will use this formula. R is equal to resistance of the wire is equal to resistivity of the wire, length of the wire divided by area of the wire. From here we can calculate the length. So length will be RA by rho. Put the value. Resistance is 10. Area is pi by 4 into this. Pi by 4 into 0.5 into 0.5 into 10 to the power minus 3 and square of it divided by rho. You can write 1 by rho. So it will be 1.6 into 10 to the power 1 divided by 1.6 into 10 to the power minus 8. Okay. So after this, you can cancel this. This will become 2. This will become 5. So it will become 5 pi. Okay. And this will be 0.5 square. And here you will have 10 to the power minus 3 square. You will get 10 to the power minus 6. Square of this will be 10 to the power minus 6. And in multiplication, this power will come. In numerator, this power is, in denominator, this power is minus. When this power will go, this 10 to the power minus 8 will go in numerator, it will become plus power. 10 to the power plus 8. And it will be divided by 1.6. Now, it will be 5 pi multiplied by 0.5, 0.5, you will get 0.25. And here you will get 100. This is 10 to the power minus 6. This is plus power. So power will add. Minus 6 plus 8, you will get plus 2. 10 to the power plus 2 is 100. This is 1.6. So it will be 25. This value will be 25 because 0.25 multiplied by 100. 25 multiplied by 5, 125 and pi. 125 and pi is 3.14 divided by 1.6. Okay, you can do the calculation further. what we will do, you will divide this value with this value, and then that value will coming, that value is coming on dividing, you will multiply this. Okay, so you will get the answer in meter. I think it will be hundreds of meter. Second question, answer B. Okay, first write down this answer B I am giving for homework. And please join the class on time. Otherwise, your syllabus will not be completed on time. Okay, write down. We have only one class in a week. In the second part, you will consider that on changing the length, there will be no change in diameter. For on changing the diameter, there will be no change in length. Okay, because already diameter of the wire as compared to the length is negligible. So if you will further increase the length, there will be no change in the wire diameter. In actual, where you will see length, if suppose this is the wire and I am increasing the length of this wire, this is a piece of wire, if I am increasing or stretching this wire, automatically the diameter will decrease. But here you will consider diameter will not decrease. Why? Because as compared to the length, diameter is small. You can see you will get length 100 meter and diameter C 0.5 mm. So you can neglect change in diameter. Done?
Yeah, the school also.
Okay, fine. Just a minute. Okay, so from the next class, join the class at the exact time. Try to join the class at the exact time, because we have only one class in a week. And we have this chapter, and this chapter will be finished in 2 lectures. And after that, we have magnetic field, I think, magnetic effect of current chapter. So we'll join the class on time, then the syllabus will be completed on time. Otherwise, 15 minutes will be wasted there. In writing also, there is a time taken. Martin, when will be your final exams of CBSE 10th class?
Board exam.
Yeah, board exams.
Like March.
In March. Okay,
Yeah.
so we can say we have time, but we should finish the syllabus as soon as possible so that you can revise the syllabus.
Yes, sir.
Hmm. Join the class only if you think that there is benefit. If you are thinking that if you are wasting your time by joining the class, please don't join the class. If you think that on joining the class, if you already know all these things, means resistance and all these things, so I think there is no need to join the class. Because if you already know, then why you are wasting your time? Because you should spend your time in other things, means in reading other subject. If there is a requirement, then you should join. Some students join the class and then leave the class at the same time. Okay, completed.
Yeah, thanks, sir.
Aman, completed. And Aman and Martin, are you understanding what I am teaching?
Yes, sir.
Okay, so
Yes,
from the
sir.
next